Okay, what's the total area under the normal curve, guys? We all agree it's 100%, so it's always the 1. Okay. Determine whether the following graph can represent a normal distribution. Well, if you see a graph, guys, that has a tail almost barely touching the x-axis and barely touching from the other side, that is called the normal curve. So yes, indeed, it is the normal curve. Well, what kind of curve? I might give you something like that. This is just a question that I gave guys last semester. I gave this curve. And I ask the students if this depicts, the normal curve. You have to say no, because the tail goes below the x-axis, the horizontal line. It shouldn't. The normal curve should always be like this. So maybe here you'll tell me we can see it is touching. Indeed, it is not touching, but it's the way, just when the computer graphs it, it can't do it, just without touching the curve. Okay, so let's go to the next question. And you can stop me at any time, guys, if you have any question. Okay, now he wants the area under the normal curve between -2.46 and 0. So guys, you know what to do here. It's a normal CDF function. Sorry. I'm going to be using this quite a bit in chapter 5. So the lower bound, as you can see, it's -2.46. The upper bound is 0. And the mean is 0 and 1, since it is about z. Remember, guys, when it is about z, it's always 0 and 1. And you put the answer right here. I might ask you to round to 2 decimal places, 3 decimal places. So you just put 0.4931. How many decimals? 4. So there will be 0.4931 and so on and so forth. For the standard normal show, okay, find the probability that z occurs on this region. Do you guys agree with me? He wants the area to the left of z equal 1.04. And again, if you use normal CDF, I'm just going to type it right here. -1,000,000, and then 1.04, comma 0, comma 1. And he gives you the tables. You don't need to use them if you know how to use the calculator there. Okay. And when we get chance later in the review, guys, I want to show you how you can use static range again with the normal calculator. What's the probability of x greater than 36? Would the students tell me what would be the 4 arguments here? Okay. What's the lower bound, guys? Yes. Let me see. 36. Very good. Upper million. Yeah, you got it. That's it. And then 50. And then 7. So if you know what you're doing, guys, this problem shouldn't even take a minute. So you just run it into the calculator. We don't use the PDF. It's always CDF, guys. So 36, a million, and then 50, and then 7. And here you go, 0.9772. In a recent year, the total score for us, this is just like your assignment, guys. The total scores for a center standardized test were normally distributed with the mean of 500, standard deviation 10.6. Answer the questions. What's the probability that the randomly selected medical students who took you will definitely, guys, for sure, you're going to get a question with several parts like this. Because that's important. You can see me emphasizing on this all the time. What's the probability randomly selected medical students who took the test had a total score that was less than 494? So here's how I like you to answer this question on your exam paper. You put probability of X less than 494 equal, then you put normal CDF, guys, and then you put the 4 arguments, 494, and then you put 500, which is the mean, and then you put the standard deviation equals, and then I'm gonna do the answer for this one, guys. Normal CDF, negative 1,000,000. This is the negative sign where I click, and then 494. Then the mean is 500. If you have any question, guys, you can ask me. 10.6. Paste. And then you come here and put, I forgot what it was, 0.2857. If he says what percent, it change it to a percent, 28.57%. What's the probability of random selected medical students who took the test as a score between 500 and 514? So it will be probability of 500 first, less than X, less than 514, equals normal CDF. You put the lower bound, which is 500, the upper bound, which is 514, the mean, which is 500, and then the standard deviation, which is 10.6, and you get the answer. What's the probability of randomly selected medical students who took the test had the total scores of more than 529? It will be probability of X more than 529 equals normal CDF, and then 529 comes first. When it is more than 1,000,000 comes next, then 500, then 10.6, and then you put the answer. Now, based on your answers, he's asking you which events are unusual. Any answer, guys, that is less than 5%, it will be unusual. Well, since I didn't compute the answers, the remaining answers, I don't know which ones are unusual. But if your answer is less than 0.05, then it is unusual. Less than 5%. Well, the first one is not unusual, guys, because it's 28.57%, but I don't know about the other two, what the answers are. Okay, so that's how you can tell. Let's go to the next question. Use the standard normal table or technology to find the z-score that corresponds to the following cumulative area. The z-score, guys, is inverse norm. And he gives you the cumulative area, which is the area to the left, 0.9559, comma 0, comma 1. And let me demo this. Second, variables. It's number 3, guys, inverse norm. 0.95591. 1.7. How many decimals is this? 3 decimal places. So your answer 1.705. When I ask on the paper, I will say 2 decimal places. So it will be 1.705 for this. Okay. The per capita energy consumption level in kilowatt hours in certain country for a recent year can be approximated by a normal distribution. What consumption level represents the 4th percentile? So he wants, X value. It's inverse norm. 4th percentile means the area to the left, guys, is 4%, 0.04. And then put the mean, which is 2306, guys. You can see it right here. And that's the standard deviation 576.8. Let's do it. I'm going to do this one. Give you the answer. Second variables of second variables, inverse norm. Okay, now let's put the values 0.04, 2306, and then the standard deviation 576.8. It's 1,296. 1,296. So your answer, guys, $1,296 for this. Okay. Consumption level in the 20th percentile. You just do the exact same work, guys, but instead of 4%, you put 20%. So it will be inverse norm 0.20, and then 2,306. And then you put the standard deviation 576.8. And then you find the answer. Consumption level represent the third quartile. Who can tell me what the percent is there for the third quartile, guys? Any participation here? Will be any participation? What would be the third quartile? Third quartile is the middle of the second half. It's 75%. Yeah, you are correct. 0.75. Comma 2306 576.8. Okay, and then you find the answer. All right. Okay. Let's continue. The graph of the waiting time in seconds at the red light is shown below on the left. This is the graph with the mean and a standard deviation. Assume a sample size of 100 is drawn from the population. This is the central limit theorem. Decide which of the graph labeled HC would most resample the sample and distribution of the sample mean. Remember, guys, when I ran the applet, regardless of how the original population looked like, the sample means will be bell-shaped. So we have to choose a bell shape from the three. So this is out. C is out because it's not bell shaped. And remember, your standard deviation of the sample mean has to be the original standard deviation divided by square root of the sample size. Well, if you take 12.9, guys, and divide it by square root of 100, it will be 12.9 divided by 10, 1.29. The only graph that I see a standard deviation 1.29 is A. So that's the answer right here, A. Graph A, mu, the mean is the same as the original mean, which is 18.5, and the standard deviation is 1.29, and the graph is bell-shaped. Okay, let me just clear all drawing here. Same thing, guys. The height of fully grown space are known with a mean of 65 standard deviation, 6 random sample of size 14 are drawn. What's the use the central limit theorem to find the mean and the standard error of the mean or standard deviation of the sample mean. We remember from the applet, guys, the mean is the same as the original mean, which is 65.5. And your standard deviation will be the original standard deviation, guys, which is 6.75 feet, but divided by square root of 14. And here is how you put the square root of 14 there. Okay. Now, if you take 6.75 divided by square root of 14, guys, that would be what? Let me just do it. 6.75 divided by square root of 14. Okay, I got about 1.8. Choose the correct graph. So it can't be this because I need a mean to be 65.5. So it could be this or that. Now, is it B or C? The standard deviation is 1.8. So we have to add 1.8 3 times to the right and 3 times to the left. If let's say 1.8 is about 2, guys. If you add 2, that should take me 65.5, 67.5, 69.5. Look, this is 79. It can't be the correct answer. So it must be this. That's the answer. Find the probability. Okay, the population mean annual salary for environmental compliance specialist is about 64,500. A random sample of 38 specialists is drawn from this population. This is section 5.4. What's the probability that the mean sample salary is less than 61,000? Assume that sigma is 5,700. So here's how this is going to be, guys. Less than 61,000, normal CDF, negative a million, 65,000, comma. Mean is, he says, 64,500. And here's where you have to pay attention, guys. When he gives you a sample size and he wants the probability of the sample mean, you just take the standard deviation 5,700 and divide it by the sample, the square root of the sample size, 38. And then you can find the answer right here, guys. You run it into your calculator. So this is the probability of X bar, not X bar less than 61,000. So that's what you need to be aware of in this chapter here. So it's probability of X bar less than 61,000. Okay. And that's, you just find the answer. Okay, so I'm going to move to the next question. Okay, now we're in chapter 6. Find the margin of error for the given values. Okay, let's do this. Okay, he gives you sigma, he gives you C, and he gives you N. And the formula for the margin of error, guys, E is ZC, which is for 95% is 1.96 times sigma, which is 2.6 divided by square root of the sample size, which is square root of 36. And let's do it together. So if I am to type it right here, it would have been 1.96, that's a critical value, times 2.6 divided by square root. So I've just put it there, guys, so you know what formula. So, and if you do the math, 1.96 times 2.6 divided by square root of 36, I get 0.849. He says 3 decimal places, so your answer will be 0.849. Okay, let me move to the next question. Use the confidence interval to find the margin of error and the sample mean. Remember, guys, when we first started, when we did that on Monday, if you have the interval to find the margin of error, you subtract the lower from the higher and say divide by 2. So it will be 0.450 minus 0.334 and divide by 2. For the sample mean, which is the middle value, you just add them up. So it will be 0. And divide by 2. 0.450. I trust that you know how to do division and addition, and then that's how you do it. Find the minimum sample size needed to estimate mu for the given values. So n is, this is the formula, guys. It is ZC times sigma divided by E raised to the second power when you estimate the mean. Okay, for a 98%, we need to find ZC. It's not one of the 90, 95, 99. Let me show you how to do it, guys, using the calculator for the confidence to find the critical value. Take 100% and subtract 98%. You get 2%. Divide 2% by 2, you get 1%, which is 0.01, guys. Now go to inverse norm. Put 0.01 here. Put 0 and put 1. You find the z-score. It's 2.33, rounded to 2 decimal places. So this is going to be, I'm going to go back here now. 2.33 times sigma, which is 6.4, divided by E, which is 1. And then I'm going to close the parentheses and raise to the second power. That's the formula. You will be provided with the formula. So that will be 2.33 times 6.4 divided by 1 and then raised to the second power. I got 222.367. Remember, you have to round up this answer, guys. So your answer should be 223 for this one. You are given the sample mean and the population standard deviation. Once he gives you the population standard deviation, guys, you're stuck with Z. You must use Z interval. That's very, very important to realize that. Z. Okay, find a 90% confidence interval, 95%. Let's do the calculator for this. All right, ready for the calculator. So second, sorry, not second, stat, tests, and we know it's Z interval because he says I'm giving you the population standard deviation. Stats. Okay, let's see what he gives us. For a random sample of 36 business days, the mean closing price is 123.87. Assume population standard deviation 11.29. So you start 11.29. X bar is the mean closing price, which is 123.87. And then N is 36, guys, and choose the confidence level 90 to begin with. And the interval is 120.77, 126.97. That's the first interval. Now he wants a 95% confidence interval. Watch. Oh, sorry, I keep pushing. Stat, tests. So we're reviewing what we learned on Monday and today. Look, guys, the only thing I need to change the 90 to 95. There you go. That's the interval. We're 95% confident that the true mean is between 120.18 and 127.56. Okay, since this is a test on campus, I'm not going to give you probably something like that. You just probably I'll ask you to interpret the answer, and you say, with 90% confidence, the true mean is between this and that. With 95% confidence, the true mean. Now, which one is wider? It's always the one that has a larger confidence level is a wider interval. All right. A publisher wants to estimate the mean length of time for all adults spent reading newspapers. To determine, the publisher takes a random sample of 15. The publisher assumes that sigma is 2.3 and the population of time is normally distributed. construct a 90 and 90%, 99% confidence. Once he gives you sigma, guys, we have to use Z interval. Well, actually, I'm going to show you how to do this. So you put the data in L1 and then run a Z interval. I'm going to show you how we could use static crunch while doing the homework as well. Watch. Okay, here's the data. You go to stat. Okay, since we know sigma is given, it's a Z statistics, guys. Z, one sample with data. He gave us the data. It's in variable one. He gave us the standard deviation, which is, what was 2.3. So you just put it right here. And what's the confidence level he wants? 90% right here, 0.90. Look, guys, there's the confidence interval. 7.4898, 9.44. That's the first one. Now for 95%, watch. Z stats, one sample with data, choose variable one. Standard deviation was given to be 2.3. And now, guys, I'm going to change the confidence level to 95. And here's the second interval. So that's how you use static crunch to do this. Now, using the calculator, guys, let's do it together. Stat, edit, and let's enter the values. So we got 11, 10, 12, 7, 7, 7. Now I got 8, 6, 8, 6, 6, 9, 12, 10, and 8. There you go. You go to stat. Usually it is a T interval if he doesn't give you sigma, but it happened that he gave us sigma here. So we're stuck with Z. Z interval, data. I have the data. And look, guys, he's asking you to input sigma, which is 2.3. If there was no sigma, and frequency, leave it always at 1, and then you can do the 90 and 95% here. There's the interval, guys. Which interval is wider? It's always the 99% interval. Find the critical value TC for confidence level of 98 and sample size 21. And he has the table for us, guys. Look. Okay. Confidence level 98 is right here. You can see the 98, guys. Right here. And then N is 21. You need degrees of freedom. Degrees of freedom, as I explained last time we met, it's sample size -1. So we need 20. So you just scroll down to 20 and then confidence level. So it will be 2.528. I can close that. You see the table pops up if you need it. Construct the indicated confidence interval for the population mean. Okay, I'm going to use the calculator for this. Clear stat. Do you notice, guys, he says S here. Once he put S, that's a sample standard deviation. This is why I like you to walk out of here today, knowing the difference between T and Z. When he gives you S, it's a T interval. So you just go to stat. If you know the difference between the two, guys, nothing is going to go wrong. That's very important. So T interval. And I don't have data here. I have a summary. So stats. And look, X bar is 12.5. And look at the prompt, guys. It says S. Then you're right. You're in the right window. If you use Z, it's going to say sigma. That's you're in the wrong window. So that's a 3. Sample size is 9. And confidence level is 90. So we're good. And that's the interval. Enter. Okay. So that's how we do that. Next one. Let me just remove that Z so you don't think it's always Z here. In a random sample of 10 people, the mean driving distance to work was 223.3. That's X bar. And the standard deviation was 5.1. He didn't say population standard deviation. He's talking about the sample. So that's S. So guys, right here, this is X bar, and this is S. Unless if he says population standard deviation, guys, it is S. Assume that the population is normally distributed, that the we have bell-shaped curve. And use that, you see, he give you a hint, use the t-distribution to find the margin of error and construct a 95% confidence interval. Okay, I'm gonna show you guys how to do this using technology. We'll find the interval first, and then I'll show you how to go back and write the margin of error. So let's go to the calculator. Stat, tests, T interval. Well, he says T distribution, guys. You can't just use Z. X bar is 23.3. S is 5.1. N is, what was N? A random sample of 10 people, 10. And confidence level 95. Okay, we're good. Calculate. That's the interval. So you got the answer for the interval. Now with the margin of error, guys, let's show you how to find the margin of error. You will take 26.9. Oops, I forgot. Let me just do it one more time. I need the two values actually. Okay. You take 26.948 minus 19.652 and then divide the answer by 2. So your margin of error will be 26.948 minus 19.652 divided by 2, which is 3.648. Another way, guys, to find the margin of error is to use the formula. But if you want to use technology, I'm showing you how to use technology here. The formula that I gave you for E was this. TC S divided by square root of N. And that's S here, guys. Okay, but you need to find TC. And in order to find TC, you need table 5, which actually it should pop up here. It didn't pop up, that's strange. For the table, you need table 5. Confidence level is 95% and degrees of freedom is 10 minus 1, 9. And if I look at the table right here, guys, that I have in front of me, for 95% and 9, it will give me 2.262. So you just take 2.262, multiply it by 5.1 and divide by square root of 10, that which will give you the margin of error. But you always, guys, can find the interval first, subtract the lower value from the higher value and divide by 2, you get your margin of error. Okay? So that's another way to do it. Okay, let's do this. That's we're gonna do using the calculator, of course, right here. Okay, here's how you can do this with StatCrunch, guys. That's for the homework. When you do your homework online, open in StatCrunch. He didn't give you sigma, so that's T. Go to stat, T statistics. One sample with data, select the data, select the confidence level. What did he want here? construct 95% confidence. Okay, 95% compute. There you go. That's the confidence level. The confidence interval, 716.58, 1,104. But for the sake of the test, guys, you're not going to have stat crunch. So we're going to put the numbers onto your calculator and do it. So we go to stat, edit. If you guys want to clear L1, I'm going to clear it right now and put the numbers. So let's do them together. 1427, 1230, 987, 692, 723. Please keep an eye, guys. If I make a mistake, let me know. Oops. 830, 728, 750, 545, 627, 1445, 941. Okay. Okay, here's a calculator. And guys, you go stat, tests, T interval, data. I have data now. I don't have a summary. And then list is in L1. We're good. Frequency, leave it at 1. He says 95%. And here we go. So your confidence interval is 716.59. It's exactly the same thing. And this is X bar. He wants the sample mean, guys. You get it right here. Sample standard deviation. It's right here. And then you get the answer. Okay. Next. The gas mileage and miles per gallon of 25 randomly selected sports cars are listed in the accompanying table. Assume the mileage are normally distributed. Use the standard normal or the T distribution to construct a 95% confidence interval. Well, if he gives you data, guys, you have to use T interval. He didn't give me sigma, so it's T interval. So again, you put those into your calculator, and then you go to stat, tests, T interval, select data, select the list where your data is, and run the interval, and you should get it. So it's exactly the same as the one that we did before, guys. Okay, so here we should use the T distribution. Oh, just 1 second, please. Here, one thing he put there.